Today we're going to talk about exponential operations. A power is an expression written with an exponent and a base. Here, the base 3 is the number that is used as a factor. The exponent 2 tells how many times the base 3 is used as a factor. 3 times 3 is equal to 9. A few more examples. 2 cubed tells us to have 3 2's. 2 times 2 is 4. 4 times 2 is 8. Our answer is 8. Next we have negative 2 in parentheses with the 4 as an exponent. That's actually telling us that we have 4 negative 2's. A negative times a negative is a positive 4. A negative times a negative is a positive 4. Positive 4 times positive 4 is positive 16. The next problem is a little different. The way our book teaches us is that the negative is not included in the 2 to the 4th. Thus it's written negative, which is equal to a negative 16. Please see the difference between the two problems so that we don't make mistakes later. 3 squared over 4. The square is only talking to 3. That gives me 3 times 3 over 4, which is 9/4. The parentheses with the exponent on the outside tell us that that exponent needs to go to everybody. It's going to be 3 squared and it's going to be 4 squared. That means we have 3 squared over 4 squared because we're distributing the 2 to both terms, which is 3 times 3 over 4 times 4, which gives us 9/16. An important piece of vocabulary is that any number raised to the 0 exponent always equals 1. If I have 2 to the power of 0, I simply have 1. If I have 152 to the power of 0, I still have 1. If I have a variable, an x, to the power of 0, my answer is still 1. Multiplying like bases, you add the exponents. If I have 2 cubed times 2 to the 4th, literally what that's saying is 2 times 2 times 2 times 2 to the 4th. 2 times 2 times 2 times 2. Well, that's a lot of 2's. If we add them up, I have 1, 2, 3, 4, 5, 6, 7 2's. That's the same thing as saying 2 to the 7th power. Now, if I actually want to know what that is, I can go through and multiply those. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 4 times 2 is 8. 8 times 16 is 128. So our answer is 2 to the 7th power, which is equal to 128. Your book will usually want 128, the whole number, if we're dealing with small numbers like 2, even with that big exponent. Next, I have 6 squared times 6 to the 8th power. Now, I don't want to write 6 out all of those times, so what I'm going to do is simply add the exponents. We saw with 2 to the power of 7 is a lot faster to add the exponents. 3 plus 4 is equal to 7. Well, same thing here. I have 6, 2 plus 8 is 10. I have 6 to the power of 10. Now I have 3 squared and 4 squared. Here I cannot add the exponents because the bases are different. I have a base of 3 and I have a base of 4. Because the bases are different, I can't add the exponents. However, I can find an answer. I know that 3 squared is 3 times 3, which is 9. And I know that 4 squared is 4 times 4, which is 16. All I need to do is multiply 9 times 16, which gives me 144. Variables. If I have x to the power of 4 and x to the power of 5, I have a common base. Thus, all I have to do is add the exponents. 4 plus 5 is equal to 9, which gives me x to the power of 9. Next, dividing bases. There's two ways of doing this. There's the quick and easy way, subtracting the exponents, or there's the long, more tiresome way. We'll start with the long way. 6 to the power of 5 divided by 6 cubed. What that gives you is divided by. What we can do with these is start reducing. I can cancel out 6 divided by 6 becomes a 1. 6 divided by 6 becomes a 1. Again, 6 divided by 6 becomes a 1. That leaves me with 6 times 6, 6 squared, or 36. It's a lot easier to simply say 5 minus 3 is equal to 2, and that's how I get 6 squared. Moving on, if the expression is written sideways instead of top and bottom, it makes no difference to us. We're still going to be subtracting the bottom number. Realize that whatever is after the division sign is on the bottom of the fraction. That means it would look something like this: 2 to the power of 4 over 2 cubed. Either way, I'm going to subtract. 4 minus 3 is equal to 1. That gives me 2 to the power of 1, or simply 2. You do not need to write the invisible exponent of 1. With variables, it's the same thing. I simply subtract the exponents. 7 minus 2 is equal to 5. My answer is x to the power of 5. The threes. Don't forget about your invisible exponents. Whenever you have to use exponents and they're not written, it's always going to be an invisible 1. So we always write them in so that we can see them and don't forget. For this problem, it's simply going to be 4 minus 1 is equal to 3. That gives us 3 to the power of 3, which is equal to 27. When raising an exponent to an exponent, or a power to a power, you simply multiply the exponents. This is how it looks. If I have 2 cubed to the 4th power, then that's going to be. Now, if we really wanted to, I could spread it out even farther. If we add up all of those 2's, we end up with 2 to the power of 12. Now, since these were being multiplied, we could have added all the 3's. 3 plus 3 plus 3, because multiplying bases, you add the exponents, is equal to 2 to the power of 12. Those are the long ways. The fastest, easiest way is to ask yourself, what is 3 times 4? 3 times 4 is equal to 12. My answer is 2 to the power of 12, which is equal to 4,096. Moving on to the variable, I'm going to have x and then simply multiply the 5 times 7. 5 times 7 is 35. That gives us x to the power of 35. If you have something inside the parentheses, you need to do what's inside the parentheses first. Inside the parentheses, it says 3 squared times 3 cubed. We know when multiplying bases, add the exponents. That gives us 3 to the power of 5, still raised to the power of 4. Well, 5 times 4 is 20. That gives us 3 to the power of 20. That's going to be much too big of a number, so we leave it 3 to the power of 20. Again, we have parentheses, but this time there's nothing happening inside the parentheses, so we're going to go straight to multiplying our exponents. I have 2 squared raised to the power of 4th. A power to a power, we simply multiply those exponents. Gives us 2 to the power of, 2 times 4 is 8, times 3 times 5 is 15. I have 2 to the power 8 times 2 to the power 15. Multiplying like bases, add the exponents. 8 plus 15 is equal to 23. This gives me 2 to the power of 23. We have 2 to the power of 0 raised to the 4th power. Now there's two ways of doing this. You could start off by saying 2 to the power of 0. Well, I know that is 1. Any number raised to the power of 0 is 1. That leaves me with 1 to the power of 4. That's perfectly fine. Another way of doing that would be to say, what is 0 times 4? I know 0 times 4 is 0. So 2 to the power of 0 is still 1. Moving to the right, I have 3 times 0. Well, 3 times 0 is 0, so 2 to the power of 0 is simply 1. 1 times 1 is still just 1. My answer is only 1. All right, now let's combine some of the things that we've talked about. On the far left, I have x to the 5th power times x to the 2nd power all over x to the 3rd power. Yes, there's more than one way of doing this. However, I'm going to do it the most simple way. Multiplying like bases, we add the exponents. 5 plus 2 is 7. X to the power of 7 divided by x cubed. Now I have like bases being divided. 3 minus 7 is equal to x to the power of 4. Moving to the right, I have x cubed, y squared, x squared, in parentheses with a 5 on the outside. Now I always take care of the inside the parentheses first. If I have x cubed on top and I have x squared on the bottom, I'm subtracting. 3 minus 2 is equal to 1. The bottom one cancels out completely because I have more on top. The 3 canceled out and became x to the power of 1. Now I distribute the 5 in. 5 times 2, 5 times 1. The reason we're multiplying is because when we raise a power to a power, we multiply. That gives us x to the power of 1 times 5, which is 5, and y to the power of 2 times 5, which is 10. One more time, we have x to the power of 7 over x squared, x cubed. I'm going to take care of our like terms on the bottom first. I'm multiplying, which means I add the exponents. The x to the power of 7 has not changed yet. It's going to be over 2 plus 3 is 5, x to the power of 5, still raised to the 2nd power. Now I'm dividing. x7 divided by x5. Well, 7 minus 5 is equal to 2. I have more on top, so the bottom one cancels out completely. The top one cancels out and becomes a 2. That leaves me with x squared raised to the power of 2, which is 2 times 2 equals 4. X to the power of 4. Fractional exponents. You might not realize this, but you've already been working with fractional exponents. When we were talking about square roots and cubed roots and fourth roots, you've been dealing with a fractional exponent. The way this works is that you have a power, what we've been doing earlier in the lesson, divided by a root. Well, we know roots as square root. So if I have 9 to the power of 1/2, that means I'm going to have the square root of 9. Well, the square root of 9 is simply 3. If I have 81 to the 1/4 power, that means I have a fourth root. Remember, the 4 is the index, and that tells you how many times you need something out of it. Well, I know 81 breaks into 9 times 9, and 9 breaks into a set of 3's. I need 4 of the same number, and luckily I have 4 3's. My answer to the fourth root of 81 is 3. My answer to 81 to the power of 1/4 is the same. We put the bottom number as the root or the index, and the top number goes as a power or an exponent. So let's take a look at 27 raised to the 2/3. The 27 is my base. It's the big number that's going to be inside the radical symbol, which is called the radicand. The 2 is my exponent. It's literally saying 27 squared. Now the square can go on the inside or on the outside. When you have a problem given to you with the square on the inside, you can move it to the outside. If you'd prefer to move it from the outside to the inside, that's perfectly fine. The 3 down below is what goes in the little crooks. That's your root or your index that tells you how many of something you need. For this problem, it's fastest and easiest to take the root first. Well, the cubed root of 27 is 3 times 3 times 3, so that's 3, and I still have squared. So that's going to equal 9. This is 27 squared with the cubed root. 32 to the 4/5. So I write this with a big radical sign. My 32 is my radicand. The 5 is my index, and the 4 is my exponent. That means I need to figure out what the fifth root of 32 is. Well, the fifth root of 32 is 2, still raised to the fourth power. 2 to the fourth power is equal to 16. Next, I have 216 raised to the 2/3 power. I draw my square root symbol. I write the 216 on the inside. I know that it's being squared, and I know the 3 is my index. I need to figure out what three things multiply to 216. Well, I know that 216 is 6 times 6 times 6. That means the cubed root of 216 is 6, and I'm still squaring it, which is equal to 36. Here, I'm going to take care of the inside of the parentheses first. I have 4 squared times 4 to the fifth power. I have like bases, so I'm going to add the exponents. That's going to give me 4 to the power of 7 divided by 4 to the power of 4 with the 1/2 still there. Next, I'm dividing like bases, which means I can subtract the exponents. 7 minus 4 is equal to 3. That gives me 4 to the power of 3, still raised to the 1/2. Next, I have to multiply when I'm raising a power to a power. So that gives me 3 times 1/2. Remember, 3 is over an invisible 1. That gives me 3/2. So I rewrite it. 4 to the power of 3/2. I draw my root symbol. It's 4, goes on the inside. The 3 is my exponent, it's the big number on top, and the 2 is the number on the bottom. I know it's going to be a square root. Well, the square root of 4 is 2, and it's still being cubed. 2 cubed is equal to 8. Let's try another. 5/12 to the power of 0/5. Well, wait a second, think really hard. 0 divided by 5 is simply 0. That's 512 to the power of 0. Well, any number to the power of 0 is equal to 1. Just that simple. Next, I have 0 to the 4/5. Well, think about it. What's 0 times any number? 0 times any number is still 0. So if I want the fifth root of 0, it's still 0. If I want 0 to the fourth power, it's still 0. My answer is 0. Negative exponents. They tell you to flip it. What you do is you move the negative exponent either up or down. This makes it a positive exponent. Realize the negative sign on the exponent has nothing to do with your number being positive or negative. So let's take a look. I have 2 to the negative third power. I need to flip it, but wait a second. 2 is not a fraction. How do I flip it? Simple. All numbers are fractions. 2 is over an invisible 1. What I need to do is flip this thing upside down. The 2 has a -3 exponent on the top. It's a numerator. In order to make it happy, I move it down to a denominator. 2 to the power of 3. Whenever I flip a number from a numerator to a denominator, I'm always change the sign on the exponent. That's why that -3 becomes a positive 3. But I don't have anything left to write on top. So what do I put? Well, if you have nothing to write on top, put an invisible 1. So I simply write 1 on top. Now, they may want you to multiply it out. Gives you 1 over 8. 3 cubed over 4 to the power of -2. Notice, the 3 cubed has a positive exponent. He's happy. I leave him alone. If the exponent is happy, you don't touch it. Think of a little sleeping baby. Happy, not bothering anybody. You leave him alone. But if the baby is negative and whining, like the -2 exponent, then we need to do something. We need to comfort it. We need to do anything to get the baby to stop crying. So that's the one you want to touch. We don't touch the 3 cubed. We leave him alone. The 4 to the -2 is on the bottom. It's a denominator. So what we have to do is move it to the top in order to make it happy. That gives us 3 to the power of 3 times 4 squared. When I moved the 4 from the bottom to the top, the exponent became positive. That's going to give me 27 times 16, which is equal to 432. Negative 2 to the power of negative 3. I want to reiterate this. This negative on the exponent has nothing to do with the negative on the 2. The two are completely different and they have nothing to do with each other. The negative 3 tells us that we need to flip this upside down. Well, we already did something similar. Remember, this is over an invisible 1. This negative tells me to flip it from the numerator to the denominator. That would give me, in the denominator, negative 2 to the power of 3. Since there's nothing left on top, I write the invisible 1. That leaves me with 1 over, well, negative 2 times negative 2 times negative 2, negative times negative times negative, is a negative. 2 times 2 times 2 is 8. Negative 8. Never leave your negative sign on the bottom. We always either put it on top or in the middle. Negative 1 over 8. Let's try another one. I have x to the negative 3 over y squared. Again, if we look at it closely, I know the y squared, he has a positive exponent, so he's perfectly happy. We leave him on the bottom, y squared. The x to the negative 3, he's not happy as a numerator, so I need to bring him down to the denominator, x cubed. If you have nothing left on top, you put the invisible 1. What if you have a whole bunch of pieces? Well, if you have a whole bunch of pieces, you need to treat them as individuals. Just like if you have lots of siblings, you want to be treated as an individual, not the same way as your sibling. When we look at this, the x cubed is happy where he is in the numerator. He's positive there, so we leave him alone. The x cubed stays in the numerator. The y to the negative 2, he's in the numerator, but he is negative, so that means we need to flip him down to the denominator. Y, now he's positive 2. The z to the negative 4, again, he's very negative down there in the denominator, so that negative sign down there tells me that we need to flip him to the top. Z to the power of 4. Now all of my exponents are happy. Again, I have two numbers, one positive, one negative. We treat them as individuals. The x squared, he's perfectly happy where he is. Well, where is he? He is a numerator. That's why we draw our invisible 1. X squared stays where he is on top. The y to the negative 3, he's not happy as a numerator, so we need to flip him to the bottom. Y cubed on the bottom.